Now, the main principle of multi-carrier systems is, as we said earlier, we divide the large bandwidth into n smaller bandwidths or subcarriers. Okay, so in this case we have reduced the bandwidth. Consequently, the symbol time will increases. It will increase n times, of course. So we have the bit stream will be divided into n streams, of course. Each of them will be loaded onto a separate subcarrier. On each subcarrier, we will have a linear modulation like BPSK, phase shift keying, or QAM. Depends on the required data rate, right? So if n is sufficiently large, then the bandwidth will be much smaller than the QoS bandwidth, and then the frequency selective fading will be converted into flat fading. Okay, in the time domain it will be the opposite. The subcarrier symbol will be increased in time, right? And it will be much larger than the delay spread, and hence it will reduce ISI. So what we have here is something like this. In order to implement the multi-carrier system, they used to do it by using frequency division multiplexing, right? So we have this bit stream here, then we convert into parallel bit streams, right? In each bit stream we use a different modulator. Symbol mapper here is called. So here maybe we can use BPSK. Here we can use 16 QAM, right? Here maybe we can use 46 QAM. Okay, then we use a pulse shape, and usually it is square root raised cosine pulse shape. Then here we modulate it using different subcarrier frequency. Then we add them up and send them to the RF front end. At the receiver, we need to extract each subcarrier alone, so we need a bank of band pass filter. Each filter is tuned to the subcarrier center frequency, and then we do the opposite. We demodulate, and then we convert serial streams into parallel streams, and we give the data back to the user. Right. However, this is difficult to implement because we need a bank of modulators and a bank in the transmitter, and a bank of bandpass filters in the receiver, right? So if we look at it, let's say that we need n subcarriers, and we are using root raised cosine pulse shape. So we need to add beta, which is the roll-off factor, and of course epsilon is an additional bandwidth required as a guard band, right? So the overall bandwidth will be a bit larger than the expected bandwidth, right? So here n is the subcarrier symbol period, right? So we have this amount of excess bandwidth that is not used for transmission, which is considered as a waste. So this way, the traditional way, is inefficient way of implementing multi-carrier systems.